Okay, good morning. Monday morning, time to get started. And let me clean up my desktop a little bit here. Get rid of some of this stuff. Close that. Admitting everyone. All right. Full week for us. You have a test Thursday. If you're looking in Mom, you won't see it until Thursday. It shows up on Thursday, and it's only available on Thursday. You get 1 hour to complete your test once you open that test. So, you want to have a good situation, time to sit down, take your test. Once it's on a clock. Once you start that test, you've got 1 hour to finish it. You can work through the problem, work ahead, work backwards, kind of like your homework, but you got to click that submit button to turn everything in within an hour. All right. We'll go over that. Any questions you might have. Wednesday is planned as a review day. We have a couple of sections to get through before then. And so I'm going to do my best to get us there, right? Get through those sections. I keep checking, letting people in. And so I'm going to start today with part of section 1.9. 1.9 is called properties of real numbers. And there are several concepts that are presented in this section, just basic relationships between the numbers that we work with in our system. I'm going to focus on one of them in particular, one of the properties that we're going to need to use right away. The other concepts, really, I'm going to kind of save in the interest of time. They actually apply really well to the beginning of chapter 2, and I'll come back and it's really kind of like show and tell and talk about why we get to do certain things with our number system. But 1.9, the one topic that we do want to practice in operation more or less is the distributive property. Many of you probably have heard of this one before. So I'm going to start with that concept today. Be the main thing, still the only thing I want to cover in 1.9, and then we'll try to get to 1.10, where we deal with conversion factors, converting from one kind of unit to another kind of unit. All right. So distributive property. And it's really understanding sort of a shortcut that we get to do with our sort of order of operations in some sense. So just to build it up, if I have a number and I multiply, times 2, 2 times 3, remember multiplication is just repeated addition. So that means I have 2 of these, I'm adding them together. Right? Well, if I'm doing the same thing with an expression, 2 times this expression, that means I have 2 of those expressions that I'm trying to add together. All right. And here's the long story, and of course the shortcut coming up. Well, and so if I look at what I have over here, I don't really need parentheses anymore because it's just a bunch of additions. I have some x's, some like terms, so really I have 2 times the x's, and I have some 5's, so I have 2 times the 5's. Right? And so I call this 2x plus 10. Looking back at where we started, how does that relate to this original expression? It's this outside number that's multiplying the quantity times each of the terms inside. So what I always do, you see in books too, is like 2 times that number and 2 times that number. That's what we're looking for. So I get the 2x plus 10. Same thing right there. That's the gist, the basics of the distributive property. And where's my erasing rag? Hang on. Yeah. There we go. All right. So, of course, now how do we get more complicated? Well, yeah. I had some tape on here this weekend. I got to clean that off better. Well, what if I have a negative number outside? Oh, let's just make that a different number. Let's call that All right. Well, so it just means I have -3 times each term inside.
Is that a 4?
It is. It's hard to
Can
see.
you make it more clear?
Yeah.
Thank you.
Yeah, maybe it's time for me to change pens too. I noticed. Let's try that too, all right? And they don't last forever. So -3 times that, -3 times that. How about -6 of those? -3 times +4 is -12. All right, does that look okay? So it was a negative times each of those values inside. There goes again. No matter what's inside, how many terms, what might be inside there? I wonder if it's my lighting. It looks a little glary today. This is saying I want 5 of every term that's inside. I distribute the 5 to each of those pieces. 5 times that, and times that. So this is like -1, right? So I get -5 of the x squares. Here I get +15 of the x's, and finally +35. Distribute 5 times each of those. Now let somebody in here. Good. All right, going on again. Sometimes you'll see some that just look like this. A negative sign in front. You can almost imply a 1 there, where it's saying, you might think that I'm subtracting all those, like, or minus times each of those. So a negative times 4x and a negative times 7, -4x minus 7. All right. Places people make mistakes.
I have a question on that one.
Okay.
So would it be wrong if I put -4 plus the -7?
How about that?
Yeah, that's how I wrote it. Is that totally fine? Okay.
Usually we kind of get understanding that adding a negative number is equivalent to subtracting. We kind of like to get comfortable with that idea. Either way works. You're correct. Okay. Notice I would want the extra parentheses here. Yes. All right. So how about this one? For some reason, people will distribute to the first number and then not either forget to distribute to the next term, or in particular, not distribute the negative to every piece. So this is saying -2 times each of these terms, and I purposely made this one a negative. I'm going to get a negative times a negative at this point. So this results in, well, -2 of those, -2 of those, -10x's, minus minus is +8. Okay. Issues, let's see. Here's one of those that I've sometimes called, this is like a trap, a trick problem in an order of operations problem. And there's something visual about, oh, 7 minus 3, that's just 4. No, this is a number standalone 7, and it's subtracted from whatever all this other stuff is. And that includes a multiplication. Order of operations says we have to multiply first. In order to multiply, I'm going to distribute. And then I'm going to see if I can combine anything. So that's the thing to avoid is you can't combine those two numbers. This is 3 of something, and this is just a 7. Right? Don't try to make it a 4 right away. So the 7's going to stay there. Now I'm going to think of this as -3 times each of those. So I'm going to get -3x minus 3. So there I did my distributing, kind of unlocked the x from inside the parentheses along with the constant value. Look for like terms. I have a 7 minus a 3, so I could combine the constants and say that's 4. And if for some reason you did negative 3x plus 4 the other order, that's totally fine. That's one of those properties we're not really talking about at the moment. Commutative says we can change positions for some things. All right, moving on. So then you'll get to some that, a couple of those big pieces you have to distribute to. Here's a longer expression. Here's one big term with some multiple pieces inside, and another big term, multiple pieces inside. And both of them now require some distributing. So I'm going to do each of them to, distribute separately 2 of these things and negative 3 of those things. And then I'll look to see if I have some like terms. So 2 of each of those. Negative 3 times each of those. Negative 12x minus minus is plus 21. Okay. Like terms. Do I have a bunch of x's to put together? I have 2 of them, minus 12 of them. Means I have negative 10 x's combined. Constants, 10 plus 21, I get a 31. Banging around. All right. See you writing, so I slow down. I wait. Try. And just maybe one more of those. Kind of like that one where I just said, sometimes there's just a minus sign. There's no number. Well, that's like having a 1 there that we don't bother to show. Right, so I still have these 2 separate terms with distributing to be done. So I want 6 of all this. And then really I'm going to do negative times both of those. So here, what do I get? 30x plus a 12 minus an x minus a 7. Distribute that negative. That's one of the most common errors. People drop the ball, however you want to say that. They forget that every piece has to be multiplied times that negative 1. 30 x's minus 1 of those x's, 29 x's left. 7 minus 7, right? Looking over here already. 12 minus 7, so 5. That's right.
So why does that minus x plus 7 become a negative? Like, why does it become minus 7? I don't quite understand how that applies. Is it because you're timesing anything in there by a negative, so it becomes a negative almost? Is that?
I mean, that's kind of like the easiest way to think of it is I'm multiplying everything, or it's usually harder to just demonstrate when we talk about subtraction, but
Can't hear you.
I can't hear you at all. I don't know if it's my microphone or if it's yours.
You can't hear you.
Okay, it's not just me. Okay.
Say
Like
again.
either I've had a stroke or it's my microphone.
Negative. You're kind of muffled.
Can't hear you.
Sounds like you're like yards away.
Yards away, huh? Let's see. Let me. The other thing to do would be just completely stop and start again. That's really, does it sound like I'm at a distance?
We still can't hear you.
Can't hear me, huh? Uh-oh.
We can hear.
I can hear you a little bit.
Yeah, we can hear you a little bit. It's just, it's,
You're way quieter than everyone else.
And it's,
Yeah.
yeah, quieter than usual, huh? That's no good. Hey,
It's like they have you at a whisper.
gee. Let me check a setting here. You know what, folks? I'm going to shut down the meeting and then
Oh.
you stay there. I'm going to log off and log back on and see what happens.
Okay.
So here we go.